Hi everyone, good day, good afternoon for everybody who's joining, good night for all the people who are watching us from Asia. Right now here with us, we have Julian Rodriguez from our Rift team and Johann Eid from Chainlink. Today we are quite excited because a couple of weeks ago we announced an integration with the Chainlink team, and right now we're going to see how a demo is done. And so we have the two product owners with us who, will explain how it actually works on a technical perspective. As if you're new to our webinars,
it's cutting off, no?
Or you want to do a comment, you can do it privately or.
I think we lost you, Fran, there a bit, but you were saying that they can send comments and then at the end we will answer questions, right?
Exactly, yes. You can write on the chat box or use.
Okay, yes, I think we lost him. This happens.
Should we maybe get started?
Or? Yeah, let's get started, Johan.
All right, yeah, perfect. Hey, everyone. Thank you all for joining. Yeah, I think for the sake of context, I'm first going to discuss Chainlink, what you're doing exactly, what the project revolves around, and then Julian will go into the integration and all of the cool stuff we've been working on together. So without further ado, I'm going to share my screen. All right, you should be able to see my screen right now. So first, to define Chainlink, it's probably better to start with what the Oracle problem is, right? The Oracle problem, high level, is basically smart contracts have a lot of capacity. Smart contracts are basically deterministic instruments which allow us to execute any kind of code and any kind of output in a deterministic manner, right? So if you get the right inputs, you're able to know the outcome. And that has extremely strong properties in the real world, right? In the real world, currently, we rely on third parties to be able to arbitrage contracts between different kind of parties, right? However, with smart contracts, we're able to rely on a platform like RSK, like Ethereum, in order to determine events between two different parties. And that's extremely powerful. Now, one of the issues we face in the world of Ethereum and RSK and any other blockchains is basically they don't have access to real world data, right? So a blockchain is a siloed entity. It doesn't have access to data such as market data, such as weather data. All of these data points are not accessible, right? And our vision at Chainlink is to see how we can go from a smart contract world, which is currently dominated mostly by tokenization, which means currently, because you don't really have access to many kind of real world events, you're not able to really create the applications you'd like to create, to a world where basically we have much more kind of real world events driving smart contracts on the blockchain, right? And one of the things we've seen actually, which does go well with our visions there, is the rise of DeFi. And basically what DeFi was, it was the rise of in the contracts, financial contracts between different parties. And these contracts could be anything from borrowing and lending to minting synthetic assets to having insurance around contracts. It's basically been creating an ecosystem where instead of the only value being the token itself, it was actually the result of a computation which gave you a certain output, right? And this output could be, I put some tokens into a protocol like Aave, and I'm able to get some token back. I'm able to borrow something against this token, this collateral I put up, right? And this was all allowed by, first, of course, the underlying infrastructure, the blockchain, but also the off-chain component. The off-chain component being the Chainlink oracles, which are able to feed price data into the contract, into the blockchain, basically. So end-to-end reliability is basically the promise for a smart contract. We basically want any user who's interacting with a smart contract platform to have the same kind of reliability that the smart contract platform offers for his oracles, right? So let's say you're, well, we know, of course, that RSK, Ethereum are all secured by consensus mechanisms where multiple nodes from all over the world can agree on a common state for a network, right? Well, our goal for the data which is being fed to smart contracts is that multiple nodes from all over the world, so fully decentralized system, can come to consensus on the state of the data point, which is being fed to the contracts, right? And that's what basically we call Chainlink price feeds. Chainlink price feeds are reference contracts, which are deployed on blockchain and which should be deployed on RSK on testnet right now, where basically you have nodes from all over the world, which are fetching data from multiple different APIs and which come on consensus on the state of the data, right? It's applying the same kind of decentralization properties that Ethereum, Bitcoin, RSK have to the smart contract kind of price feeds we're feeding and we're creating. And basically what these price feeds allow you to do is to have all of this DeFi ecosystem, which we've seen popping up recently. So as an interesting point, currently, I won't go over all the slides, by the way, it's a lot of slides, which we don't have time for, but currently around $3 billion. So this slide is not completely up to date. It's currently $3 billion are being secured by the Chainlink price feeds. And these Chainlink price feeds are being used to allow for borrowing, lending, asset management, triggering liquidations for synthetic assets, for collateral platforms. Basically, the price feeds have been the center and an integral component of everything we've seen popping up recently with the DeFi economy, right? So without the price feeds, it's very likely that we wouldn't have this ecosystem which we have today, just because market prices are driving most of these applications we have on Ethereum today. Like, you cannot have a lending platform if you don't know the value of the collateral being put up in US dollar, right? You cannot have a synthetic platform if you don't know the price of gold, of silver, of oil. You can't have all of these applications basically without oracles, because oracles are the one which feed you price data. And just like we've seen this new DeFi ecosystem relying so much on pricing data and other kind of data points which are being fed by Chainlink oracles, we expect that any ecosystem in the future will rely on them as well. That means insurance, that means supply chain, all of these different kind of ecosystems which will start popping up in the blockchain ecosystem will rely on this real-world data. So our vision currently was to provide all of these data points to the DeFi ecosystem on Ethereum, and that's part of our kind of collaboration with RSK. We're also planning to move to other chains, to support other chains, right? Like, we want to have other chains like the one like RSK to be able to integrate Chainlink, and that's why we have such a blockchain agnostic kind of vision, where we have off-chain components which can be adapted. So we have what we call an initiator and an adapter, which the RSK team actually worked on. And the initiator is used to monitor a new blockchain environment, right? So this could be Ethereum, but this can be RSK, this can be Bitcoin, this can be anything. And the adapter, which is used to write on the chain. So the initiator watches for requests for data. So a smart contract is going to ping an oracle and say, hey, I need the price of this asset from this data source. The adapter is responsible for writing this price. And all of the on-chain contracts, which are detailed in this right section, are basically used to kind of first pick up the events, but also drive the whole token economy being used, because that's something else which is very kind of important for our ecosystem, is that node operators are paid in Link token. And something we will have with RSK is the ability for people to transfer Link token from Ethereum to RSK to pay node operators in Link whenever they make a request. So yeah, that's a very kind of rough explanation of what Chainlink does, of what we're all about and what we've been doing in the last few months. So yeah, I'll let you take it from here, Julian.
Thank you. Thank you, Johann. Very interesting. Yeah, so now I'm sharing my screen. We will go into a bit about the integration and a bit about RSK. So just for those that may not be aware, what is RSK? So RSK is the first open source platform powered by the Bitcoin network. Basically, what we add is we add functionality and features to the Bitcoin ecosystem. Among those features, we have the execution of smart contracts, which is something very similar to what you can do in Ethereum, but using Bitcoin as a native token or currency. It allows for near instant payments and higher scalability. So how do we do? How do we add this additional functionality and value to the Bitcoin ecosystem? We do it technically through a sidechain. This sidechain contains a two-way peg connected to sort of the Bitcoin blockchain. So basically, you lock some Bitcoin on some address on the Bitcoin network, and that releases that BTC is converted into what we call a smart Bitcoin on RBTC on the RSK blockchain. And basically, you're gonna do all your contract execution and your logic on that blockchain. And then if you want to go back through the bridge you can go back through the bridge to the Bitcoin network. Another interesting feature beyond the two-way peg is that our blockchain is merge mined. This means that the security is provided by the same miners that are mining Bitcoin. So at the same time they are mining Bitcoin, they are mining our blockchain. So this is not a different set of miners or a different network altogether. It's merge mined. It's an interesting feature. And as I mentioned before, it's EVM-based, so allows the execution of smart contracts exactly in the same way as in Ethereum. You can develop the same smart contracts in Solidity that you can run on Ethereum. You can run them on RSK, so that allows for very easy portability of all the applications. So what is Reef, which is another component that usually you probably see? So we have here I will show our technology stack and how we see it. We have Bitcoin as the store of value, and as I mentioned, RSK as the smart contract layer that allows to execute logic on top of that network. But in order to connect that with real applications and real use cases and all these DeFi tools that we see, there's obviously a gap there that we need to cover, and that was the reason why we created Reef, which is the RSK infrastructure framework. And basically, it's a set of services, of decentralized services and libraries and tools that allow you to very easily develop these applications and DeFi solutions without dealing with all the complexities and rebuilding everything from scratch on the RSK blockchain. So among those services, we have identity services, storage, payments, communications, a marketplace, and gateways. And gateways is the one that is especially important, and we mentioned it today because it's the one that deals with oracles and all communications that are coming from the external world into the blockchain. So this project was part of the gateways integrations that we're doing, and this is the reason why it makes a lot of sense for us to have, in order to provide these solutions, we need to have Chainlink and other technologies such as Chainlink as part of the offering that we can integrate to our technologies. So about the integration itself, basically the goal was to integrate Chainlink and RSK at the technology level. So basically allow the same node operators that are now serving Ethereum with minimal changes to be able to start serving RSK. And of course, for partners and teams building on RSK to be able to benefit from having Chainlink as an Oracle provider and using these services. So we focus on doing an MVP, which is basically getting the Reef BTC pair price. And for that, we did a simple Oracle and also an aggregator, which is those price feeds that Johann mentioned. We built one of those price reference feeds just to see that both type of solutions are covered. We work together with Chainlink team. This is not something that we developed and we just, okay, let's say we went to Chainlink and said, this is our integration. We worked together. It was a nice combined effort. And not only for development, but also for the testing and validation, we did it with real Chainlink operators, which are helped us, like in this case, the word chain layer and Vulkan link. So thanks to Peter and Leo from those companies that helped us validate this solution and run these oracles on the testnet to confirm that this was working. So how is the architecture of the integration? Basically, these are the components that Johan mentioned as well. I'll get the pointer here. So basically, you start with your DeFi application that at some point will need to have a contract that is a consumer contract. It's the one that is going to be requesting the value and getting the result, right? So this contract will request a job execution to an Oracle contract that is also deployed on the RSK blockchain. And this Oracle contract will emit an event that the initiator is the one that's going to be listening. So the initiator and the adapter are the two components that allows us to connect the RSK blockchain with the Chainlink network. So basically, the initiator will be listening for job run events, and once it detects that somebody is requesting a job run, it will connect to the Chainlink network, and a Chainlink node will get the value from either an API or any other source that is the one that providing the value. Once that value, we have the return value, we use the RSK adapter to get the response back to the Oracle contract on our network. So the RSK initiator and the RSK adapter are the two custom components that help facilitate this integration. The rest, it's everything very standard, almost identical to the Ethereum, to how it's done today in the Ethereum network. So now we will go into, before there are two components that I also would like to mention that complement this architecture. As Johan mentioned, node operators will be able to get paid in Link, actually not in Link, but they will get paid in R-Link, which is basically, we have on RSK a token bridge, which allows you to move ERC20 tokens between both networks. So basically, you can send R-Link to a bridge on the Ethereum network and receive it in the same address on our chain. This is completely decentralized using smart contracts. And there is a dApp that you can access to do that very easily, which is tokenbridge.rsk.co. So that allows us to have in our network something that we call R-Link, which is basically the representation of a link that is locked on the Ethereum side. But also we use this for any other token and could be used for any type of payment in other currencies or tokens. The other interesting tool that we have that can help get this R-Link is the RSK swap. And basically, this is a fork of Uniswap that we have on RSK, which we actually have a liquidity pool that you can exchange R-Link for other currencies. So as long as there's liquidity in the pool, you don't need to go through the previous bridge. And this is an instant conversion that you can do to get R-Link, or either to convert it to Link or from R-Link to swap it for another currency. So these are two tools that are very important because they allow us to connect more the economical side, right, of the business model side of this. So without further ado, let's do the demo. I have three small videos. One is everything is in the repo that we will share, in the GitHub repo. You can run it, try it out. Basically, what I will do in this case is set up a local development. So in order to see all these services working together, so I will show how you can do it. We did something really easy. So if we connect here to you go to the repo, you will see that we have all this, a boilerplate, a Docker Compose that has all these 7 services, the Chainlink node, it will spawn an Ethereum node, the database, an RSK node, the initiator, the adapter, and a test runner script, which is basically a script that will start gluing and putting all this together and sending a request. So basically, you clone the repo, you go to the folder, which is Chainlink RSK, and you will see that there's a Docker folder. And in that Docker folder, you can simply run Docker Compose app. And this will start spawning all those things, the Ethereum node, the RSK node, the Chainlink node, the initiator, the adapter. I know that there are a lot of components and a lot is going on, but allows you to really access all these components very easily and see how it works. And we can see now it's spawning the Chainlink node, the initiator, the adapter, and it's going to do that job request. So here we can see that it started the job run with certain ID. Then we will see at the bottom that it's fulfilled, and we can see here that we received the price of the RIF price as the number in BTC. So all this whole cycle that we showed, going from in the Docker desktop, you can see the services here to see how they work. So basically, the interesting thing is that this small script that you can run basically did all that complete cycle that we showed before. It had a cycle. It basically had a consumer contract that called an Oracle contract. It went through the adapter, it went to a Chainlink node, got the information from an API, and went through the adapter back and returns the value. So all that is kind of embedded in a simple script, so you can like have a grasp of that. Then the experience from a node operator, and the goal here in this demo is to set up the environment as a node operator, run the initiator and the adapter services, and deploy an Oracle and create a job that then developers can use to connect to your oracles. So for that, basically you need to build the Docker images. In this case, we have them pre-built. So what we'll do is we will run the services, run the initiator, and run the adapter. So we'll start running the initiator. Sorry. And here we can see there are certain parameters. We run it in interactive mode. We put the name of the initiator, which is RSK initiator testnet. We set up an API file, which is the one that will be used for authentication with Chainlink. We use an M file, which is basically the configuration of the initiator. We set up some ports, and we also set up the network that you will be connecting. And once you do that, you run it. And this will start an initiator bridge through a library that is called Chainlink API Client. And you will see here that it's spawned and it's waiting for, there are no subscriptions yet, but it's connected to the RSK node already. The same for the adapter. We run the adapter, same parameters. The only difference is that here you have a key that you need to set up, which is going to be the wallet, and there we have the addresses. This is required because the adapter will be sending a transaction to the RSK blockchain with the actual results. So if we connect to the Chainlink operator UI, we will see that the bridge is created there. We see the bridge is created. So now we have the adapter and the initiators already running. So the next step is to deploy the Oracle contract that we need on the RSK network. And basically, we go to the testnet deploy folder, which is a truffle project. This you are very familiar because on Ethereum, it's exactly the same how truffle works. We install the dependencies of that truffle project. And while the dependencies install, we will check some configurations we need to do. For the migration script, which is a script that deploys the Oracle contract, we need to enter the adapter address. The contract needs to know which is going to be the adapter that is going to be sending the response in order to allow it, right, to access. So we copy the address, and we can paste that in the script. And once we have that, we can deploy the Oracle contract. So we'll go here to all these instructions, as I mentioned, in the repo. So we'll do a truffle migrate of the first two files, which are the ones that deploy the Oracle contract. we're running it against the RSK testnet network. So it's compiling. Now it's going to start deploying the actual contracts. So as I mentioned, this is very familiar to everyone that worked on the Ethereum. So just as I mentioned, you will see that in the migration script, you also have this side token address that you need to send as a parameter. And the side token is that basically, as we mentioned in the bridge, this is the address of the link token contract on the RSK network. So basically, it represents the token that is going to be used for payment to the Oracle in this scenario. So that's what we call the side token address here. So it's going to be a token address that is from a mirror contract on the Ethereum side. So and here we set the fulfillment permission, which, as I mentioned, that for the adapter address we need to give approval so the adapter can send transactions to the Oracle contract. So once this is still deploying, once the Oracle is deployed, what we will want to get from there is the Oracle address, the address of the contract. So here we have the address of the contract. And the reason for that is because now we're going to set now it looks like it's stopped there, but it's deploying, it's doing that actual approval for the adapter, sending that transaction. So once we have all the information, we need to basically create a test job. And to create a test job, we create a new job, and we provide the spec, which is this JSON file that is suggested by Chainlink and used by Chainlink. So we're going to set the 3 components that we deployed: the initiator, the adapter, and the Oracle address. And those are the 3 things that we need to configure in this job to make it available for developers to use it. So we'll put the name of the initiator, which is RSK initiator, as we deployed it, the name of the adapter. And here we'll see all the different options that Chainlink allows, the different tasks: HTTP GET, JSON parse, multiply, and the RSK TX adapter is an external task. So the thing that we need to complete is also the Oracle contract address, as I mentioned. So we'll put it there. Okay, so we'll get it from here as it finished deploying. I'll get it from here. I'm pasting the Oracle address, and now we can create the job. And now we have an ID. And this job ID is what we are going to use to send to the developers so they can use our job. So that's the experience from a node operator developer. The next scenario, and the last one, is the dApp developer. So how a dApp developer uses this, and the idea here is to configure and deploy the consumer contract, fund the consumer contract, and then run the script that calls that consumer contract. So for that, let's see demo. Basically, here's the migration script for the consumer contract, and what we need to complete is the job ID that we got from the node operator. I'll copy the same job ID that we got in the previous example. So here we have the job ID. We'll set up there. We also have the side token address, the exact same side token address that we use for the node operator. And once we have all this, we are ready to deploy the consumer contract. So we will run a shuffle migrate, just like we did with the Oracle contract, but with the consumer contract against the RSK testnet. It's compiling. And this consumer contract is also the one provided by Chainlink. It's basically the same contracts. We didn't do any changes to the actual contracts. Neither the Oracle nor the consumer. They can be used as is, as they come from Chainlink. So this is deploying. And here we have the consumer contract address. And just to look a bit at the consumer contract, here's where we specify the request ref price by callback. This is a function that will be requesting from this API. In this case, we're using liquid.com to get the ref RBTC, the ref and BTC pair. And so basically, here's the logic that will be telling the Chainlink where to get the information from. So the next step, basically, we have the contract. We need to fund it. The consumer contract needs to have funds in order to be able to send the request to the Oracle contract. So in this case, we copy the address from the RSK Explorer, and we're going to send those R links, some R links, so the consumer contract can actually do the call. So in this case, I'm using Nifty and sending 5 RCOV link, we call it, because it's in this case we're using the Covan testnet network. Now that we send the funds, it's already funded. We can execute a script that will actually be requesting this value. It will be triggering the request, and it will trigger the whole process, going through the Oracle contract emitting this event that the initiator will pick, going through the Chainlink network, and coming back the response via the adapter. So we are going to run it with an npx truffle exec. We're going to run the script. So it's requesting the ref price. We will see now in the job UI, or here we see that initiator is already subscribed to that Oracle and detected the Oracle request for that job ID. So now it's picking up that there's a request coming from the consumer contract. There is some small delay here because we're waiting for a certain number of confirmations to avoid reorganizations and things on the blockchain. So it waits for 3 confirmations at the time. So once it gets the transaction, it will initiate the job. And now we will see in the UI that the job started. In the node operator UR, we see a job. The job is in pending breach status because that's until we get the response from the adapter, it's going to be in that status. So the adapter received the request. This is the adapter screen. We received the request for that run ID, and we are sending the transaction with the actual result to the RSK blockchain. So here again, it's waiting for some confirmations. But once that is done, it will update the job with a status completed. So that whole cycle now it's over. And if we go to the Chainlink operator UI, we see that the job is now completed, and we can see that everything ran successfully. So the whole request went through that complete flow that we showed through the whole integration. Okay, so those were the demos. So what's the status of this? Basically, we have it deployed and running on the testnet. That integration is done. We have a ref BTC price aggregator that we deployed on the testnet and is in that address. The security audits and review were also completed. So the next step basically is moving it to the mainnet. We are working on that as we speak. There are conversations. It's not just about the technical. The technical part is done. We need to see how we're going to manage these oracles, what types of oracles we will be deploying, how it's going to be the governance, and things that we are discussing. But this is imminent that it will be soon moved to the mainnet. additional resources that you can find in our web portal. You have all this information. Of course, the repo that we just where we got all these scripts to run is github.com/smartcontractkit/chainlink-rsk. Of course, the documentation from Chainlink provides a lot of information about about how integrations work and the whole architecture works. Of course, in the RIF blog, we have information about this. There's also a link to an Oracle experts panel that we did, which could be interesting for you. And pay attention to webinars and stay tuned in our social networks, because we'll soon be having announcements regarding this and, of course, other interesting topics that will come up. So with that information, we are done. Fran, basically, we covered. I'm not sure if Fran is here, but I think I will move now to questions.
Yes, I'm back here. I think that.
Hi, Fran. I was trying to stop presenting.
Let me see if I can.
My
stream right now. Yeah. Now it's done. Okay, well, we have, thank you so much, both of you, Johann and Julian. I think that it was, well, pretty much clear besides of the demo, and well, afterwards we will share with you on the chat box the links you made in the presentation. And for those ones who want to see the presentation afterwards, just enter developers.rsk.com/webinars, and you will see it, all the recording and all the presentations we used here at this webinar. Well, as for questions, well, there was here one that I answered live, actually, that Julio made. It was about, well, if there was a tool similar to Remix to use an RSK. Well, we made a webinar about this. I shared the link. I'll share it with you also on the chat box, so you can see it publicly. You can use it also on RSK. That's one of the benefits we have, that besides the bridge, we can use both tools on our blockchain also. Let me see here. I think that Hector Hernandez, hi Hector, he's the CEO and, well, CSO and co-founder of TextFright. He's asking us, is there an interaction between Link and SBTC? I don't know who wants to answer that.
I don't know what maybe he meant
RBTCs.
I don't know what SBTC is, to be honest.
RBTC.
Okay. Yeah, because we call it Smart Bitcoin, but it's RBTC. The interaction, no, basically no. The link token is a token that exists on the Ethereum network. What we do with the bridge is that we can bring it to RSK, but it's a token. It's an ERC20 token that we call it R-Link. But basically, the interaction is basically at some point you will need to exchange it, like you can do any token with RBTC. It's not the relationship. It's basically R-Link is a token on top of the RSK blockchain, and RBTC, it's not a token in the RBTC blockchain. It's the actual native token, but there's no relationship beyond that. They are two different currencies. So what you will do for paying an Oracle, you will need to pay the Oracle with R-Link, but you still need gas RBTC to send the transaction. So you will need both, but there are some solutions that are coming underway for gasless transaction or being able to reduce that. Those are things that are coming on RSK.
Great. Yes. Well, Hector just answered. He completely understood it. Well, here's another one. How long does it take to get the Oracle information in my contract? Is that sync or async?
No. Yeah.
Yeah. Go ahead, Julian.
No, I would say not. I would say it's not sync, because you need to, in the blockchain, you need to write information in the blocks, and the blocks are, by definition, the blockchain is not sync. So you will send a request, and it could be in the next block, or it could be in some other feature. You will get the response, but it's not something that you will be blocking or in sync mode waiting for a certain time. You will need to, like all oracles work, the value needs to be in the blockchain and needs to be mined and available in order to read it. So you will send a request, it will trigger all these functions. At some point, it will get written into the blockchain. I know, Johann, if you wanted to say something.
Yeah, basically what you said. It's, yeah, I mean, sync in a blockchain world doesn't really exist.
Yeah.
But yeah. I see the next question, gasless transactions.
Yeah, gasless transactions is something we are working, you know, on Ethereum, you have what it's called, there's some project called the gas station, which allows you to, for wallets and applications to pay for the gas for users. So they don't need to have gas, they can just use it. And basically what you do is you use some off-chain relayers that are the ones that will be, so the user only signs the transaction and the relayer is the one that will be wrapping that and paying and sending the transaction to the blockchain. What we are doing in RSK is a solution called enveloping that will allow you to move tokens without you being the user being the one that pays the RBTC. But that's something, a complete different project. It's not related to that, and that is coming soon to RSK. But it's not related to this project. Pedro has a question there as well.
Yes.
He says,
yeah.
I just need to call the aggregator address. Yes, the aggregators basically are contracts that we call it reference contracts. Well, Chainlink call it reference contracts. They have the value there, and everybody can check the value from that. And those are the ones that are being written by a consensus of the nodes that write the value there periodically on that contract. And you just read it. I guess, all right, Johann? I was correct on that?
Sorry, I was on mute. Yeah, you are correct, exactly. Okay. The good thing with price reference contract is that it's very easy to use, right? Like it's just a read operation. So that kind of ties, I think, with the question before about sync. You know, when you request data, there is indeed an async kind of communication there. However, with price reference contracts, it's fully synced because you can read directly from the price contract. You don't have to, you know, wait for a new result. And the good thing there is you don't actually need a request on chain to trigger the update. The node operators who are updating are watching for API, like for an API kind of price API, right? In the case of, let's say, ETH or BTC. And if they see a movement between the price API and the current value on the contract, they trigger an update. So there isn't even a need to trigger the update of the price reference contract on chain. The node operators basically do it by watching from the price changes off chain. Yeah, hope that clears up things and doesn't confuse people more.
No, it was clear. So we have another question there from Mato. From the consuming perspective, there are two transactions, one to get the info and then another to consume the info and execute the logic. Yes, actually, one transaction is for the request, and then the other one for reading is not necessarily a transaction. You can just call and get the value. But yeah, assuming you will probably want to do something with the value, there might be something else that you want to execute, or you can have a fallback that as soon as you get the response, execute certain action. You don't need to do a second transaction.
Perfect. And well, Hector, and you won one mainnet. I think that he's asking for a date. Soon.
Nice. Yeah, I think, as I mentioned, it's not just the technical part. I think we need to work on the governance, which are the node operators that are going to be running this. If it's going to be, we already did with Chainlayer and Vulkan, but are we going to have more operators? We need to see which kinds of price reference we're going to deploy there, how it's going to be that model of writing to that contract, and all that. It's more like governance or more administrative things that we need to work. But I feel hopeful that in the next weeks we're going to have probably some news on that. I know, Johann, if it's a little bit beyond my scope, that part. So
I think it's mostly about, like, the node operators will come whenever there is a financial incentive, right? Because they need to be paid in link token, obviously, and there needs to be traffic. So I think it will just come up organically as more and more kind of applications on RSK needs price data, which will happen once DeFi pops up, or any kind of data. I keep saying price data because it's the main one being used right now. But any kind of data, then these applications will start paying in link token for the oracles. And then I think there will be, well, I don't think actually, it's like basic economic, like there will be kind of normal organic kind of demand, first from users, and then second from operators who will want to get a piece of that, of that business. And they will be running on RSK. Now, on our side, because a lot of node operators are extremely interested in new opportunities, I think we already have, 3-4 testing on testnet, like 3-4 like node operators were already on mainnet Ethereum and securing, part of the $3.5 billion. So like really very serious and kind of node operator companies, and I expect many more to come. So yeah, I mean, mainnet, as you said, Julian, like there is still some technical stuff to figure out. Obviously, like the price feeds, there is also monitoring around the price feeds. There also needs to be some kind of administrative power to add and remove node operators and to create networks. This power can be anyone. It can be a user, it can be RSK, it can be Chainlink, it can be a governance process, it can be a DAO. But all of these pieces need to be put in place to make it happen, right? So
yeah. What I would say is going back to the question, when the more cases, if you're really interested in this and have an actual use case that will help us work on a specific to get it to the mainnet as soon as possible, at least for that use case. So I think it's as Johann mentioned, it will be driven a lot also by the needs of the people implementing, partners implementing in RSK.
Okay, perfect. So I think, well, if anybody has a question, this is your time to type it down. If not, well, it's time to say goodbye, I think. I don't know if you want to leave any last-minute message.
I think it's extremely exciting, to be honest. I'm starting to see this movement. Like a few months ago, like maybe 9-10 months ago, there wasn't much happening in the crypto space, to be honest, right? Like I don't think there was this kind of amount of value secured, for instance, on Ethereum, on DeFi, on all of this stuff, and seeing how all of this adoption came up and seeing that a lot of applications actually are starting to move to new blockchains, right? So I see a lot of kind of enthusiasm around RSK, for instance. I think there is this kind of new period we're getting into, right? Where DeFi and kind of the crypto space is going to move more and more to a blockchain agnostic kind of vision, right? And I think that's extremely exciting because for us, and that's obviously why we want to be on RSK, that's why we want to support, because I think there is going to be this new wave of projects and kind of, being there and working with communities and seeing DeFi ecosystems pop up, not only on one particular blockchain, but across the whole kind of crypto and blockchain sphere, I think is extremely exciting. So really looking forward to this new phase in the growth of crypto.
Yeah, I agree. It's exciting, and having Chainlink, it's something that we wanted to, and we've been in conversations for a few months, and have been so close to seeing it a reality integrated to RSK. It's great for us. So we're very excited. Thanks, Hector.
Perfect. Awesome. Thank you so much, guys. Bye.
Okay, thank you. Well, goodbye, everyone.
Goodbye, everyone.